private schools, like you got the high-end Ivy ones, is
Yep.
they've been private and they do what they want anyway. They're not selling expensive educations to people that can't afford it that have no actual application.
The people that are going there usually have the money to begin with. You're right.
Yeah.
And they get in high-end jobs once they're out to pay it back. You're absolutely correct there. Okay, so yesterday we talked about ratio and proportion. And I don't have it posted yet, but at the end of class here today, I'll get posted. There'll be a quiz in ratio and proportion posted on Blackboard. It'll be due for Monday. What was that, the 25th, I believe. Again, I don't have it posted yet. I was going to get it posted before class, but I got tied up with a couple of things. It'll be out there at the very latest, by 4 o'clock this afternoon for you. And it'll be due Monday by the end of class at some point. So anyway, our next step then, first of all, were there any questions on the ratio and proportion stuff that we did over the class on Tuesday? Okay, so today we're going to look at a special application of proportions and ratios that we looked at a little bit last semester. Well, we looked at it quite a bit last semester, actually. Percents. Remember, we said that percents, the term percent, meant out of 100. So 42% meant 42 out of 100. And we've looked at that wording. We saw it a little bit on Tuesday with our basic ratios. 42 out of 100, written as a ratio, looks like that. And we can reduce it just like we would a fraction. 42 and 100 both divide by 2. That gives us 22 out of 50. When we are asked to convert a percent to fraction form, now, most textbooks, unfortunately, if you haven't figured out yet, I have a beef with the way a lot of textbooks do things. A lot of textbook writers are not math experts. They're textbook writers that have a little bit of a background in math. Most textbooks will just say convert this percent to a fraction. Well, that's not true. This isn't really a fraction. It's a ratio that's been reduced. This, it looks like a fraction. It's in fraction form, but it's a ratio, a reduced ratio. Now, one of the things that's a little foggy, because we said on Tuesday that with ratios, we reduce it, but we don't ever split it back down into a mixed number. Well, where the percents fog that a little bit is with a percent, we will convert it into a mixed number if need be. Something like 276%. If I ask you to put that into fraction form, well, it's 276 out of 100, so we'll just jump to 276 over 100. And we do see that that is bigger than 1. The numerator is bigger than the denominator. And we'll reduce it or split it up right here. 100 goes into 276 twice. That takes out 200, leaving us with 76. We do it first just because it's way easier to divide by 100 than it would be to divide by some other number after we reduce. Now both 76 and 100 can be divided by 4. 76 divided by 4 is 19, and 100 divided by 4 is 25. I left the gap there, of course, because we have to remember to put that 2 there. So if we write 276% into fraction form, we would get 2 and 19/25. Even though that's not a ratio anymore, it still comes from the ratio. So as I said, it gets a little foggy with our percents doing the conversion. Again, often a textbook will just say convert this fraction to a decimal. Well, we're not really converting to a decimal. We're converting to a rate. And a rate, as we mentioned last semester, is just the decimal form of a percent. We said 74% means 74 out of 100. And we can convert that to a decimal form by simply dividing it out. 74 divided by 100. And as we mentioned last semester, dividing by 100 just moves the decimal point over. That becomes 0.74. So we can convert our percents into that rate or decimal form by simply dividing by 100 or moving the decimal point over 2 spots. So we saw if we had 3.2%, that becomes a rate or decimal form by just doing 0.032. The decimal went over 2 spots, and we had to fill in a 0 to fill in that missing place. Or 6%, very similar. 0.06, again, had to move the decimal over 2 spots. Well, there wasn't a second spot, so we had to fill in a 0 to fill in that second place. We might have 13.25%. To convert that into a rate, we first have to convert it into a decimal percent. Now, this gets confusing because I just used the term decimal in 2 different applications here, where I use decimal here, and more specifically the term decimal form. I was referring to the rate form of a percent. When I use the term decimal down here, I'm still referring to a percent itself, not the rate form, just not having fractions in the percent, changing the fraction parts to decimals. Well, 1/4, of course, we know as a decimal is 0.25. So that becomes 13.25, and it's still a percent. So that is just the decimal percent, not the decimal form or the rate of the percent. If I wanted to turn it into decimal form, remember decimal form is the rate. Then I have to divide by 100 or move the decimal point the 2 spots to get 0.1325 as a rate. Now, there are a lot of applications we will look at where the rate is very important. One of them that we looked at last semester, of course, was that simple interest. A lot of times for business purposes, I would say a lot of times, a couple of times for business purposes, I had to go in and get a short-term loan. I needed to make the payroll for the crew that was working for me. And I hadn't finished a job for a while. I hadn't gotten my final paycheck for a couple of jobs. I wasn't going to delay payroll to wait for a job to end. So you might go to a bank and say, okay, to make my payroll, I need $2,800, and I should finish all of my jobs and get paid within 90 days. Well, the bank's going to look at that and say, okay, well, that's a small amount of money, a short term. We're going to charge you 6.5% interest. And they use the term simple interest. When we're dealing with simple interest, we typically do use the rate form of that percent. $2,800 is our base amount or principal. And we use that 0.065. 6.5%, of course, would be 6.5 as the decimal percent. So the decimal form or the rate is 0.065. But interest, that 6.5% is for 1 year. So we have to account for the fact that this is only 90 days. So there's typically 365 days in a year. They don't adjust that for leap year, by the way. So we wouldn't have, since this is a leap year this year, we would not have to do 366. They'd still only use 365. So we'd find that interest 2800 times 0.065 times 90 divided by 365 giving us $44.88. So I'm going to pay $44.88 in interest. So at the end of my 90 days, I'm going to pay back a total. I add that to my original amount borrowed, the $2,800, $2,844.88 is what I end up paying back. Now, hopefully, if you ever are in business for yourself and have employees, hopefully you don't run into that where you have to make short-term loans to make payroll. It wasn't uncommon for me. I didn't have a cash cushion because the money I made for my business went into paying for college. So I didn't have that extra, the profit laying around to cover those expenses when it happened. So I had to do those short-term loans. And that's how the process works. Well, let's take a look at just generic percent problems. And to do that, let's look at converting a fraction into a percent. Like we did again mid-semester last semester. If I have a simple fraction like 3/5, and I want to convert that into a percent, there are several ways I can do it. Now, some of you might even know that 3/5 is 60%. That's great. I mean, I chose a simple example to make the calculation a little easier for us here. But let's assume for right now that you don't just know that that's 60%. One of the ways you could approach that to figure out what it is you could turn that 3/5 into a fraction, into a decimal by doing 3 divided by 5, gives you 0.6. And we haven't reviewed it, but you know from last semester to turn a decimal into a percent, a decimal, 0.6 is out of 100, or is out of 1. Wow, I'm getting tongue-tied today. A decimal form, a rate is out of 1, 0.6 as a rate is 0.6 out of 1, and a percent is out of 100. So we're just multiplying by 100 to get from that rate to the percent. In other words, we're just moving the decimal point back 2 spots to the right. Excuse me, so that 3/5, which is 0.6 as a decimal, is 60%. Another way we could look at it is we could use a proportion, like we did yesterday. Fraction is out of, 3 out of 5 is our fraction. A percent is always out of 100. To come up with an equal proportion, we can cross them out. Since this missing item is all by itself, it's not 3x or x plus 5 or anything like that. Since it's all by itself, we can just cross multiply and divide. 3 times 100 is 300. And then the number that's diagonal with our missing number is the 5, so we're going to divide by 5. 300 divided by 5 is 60, and 60 out of 100 is 60%. So that proportion is typically the tool we use for working with percents. So if I ask you, using that proportion method, find 35% of 80. Just a quick review of our percent from last semester. Of course, we start with the 35%. That is 35 out of 100. We have to create a ratio on the other side that is equivalent to that. And remember, we talked yesterday about things having to be related. Whatever goes on top has to have a relationship with that 35, has to be connected to it somehow. Whatever goes on bottom has to have a relationship or some connection to that 100. Remember, the 100 meant the full amount, or what we call the base amount. And the 35 is the portion of interest. I'm just going to call it portion for right now. So the 80 here, we have to decide if it's the portion or the full amount. 35% of 80, that word of 80 can be read as out of 80, which implies that it out of means that it is the base amount, or the second number, the bottom number. And just like any other proportion that we've solved so far, we can cross multiply and divide. 35 times 80, is 2,800. And divide by the 100 gives us 28. So 28 is 35% of 80. We might have 130% of 40 is blank. Two things are different about this problem than the last example. One, of course, is the wording and setup is very different. We just put the wording in a different order. The second thing that's different is our percent here, 130%, is bigger than 100. Remember, 100% is equal to the full amount. Or one whole thing is 100%. 130%, bigger than 100%, means it's got to be bigger than the full amount, or bigger than the base amount, in other words. Well, 130% is still written as 130 out of 100. Of 40, again, we could read that as out of 40, still implies that the 40 is the bottom number. We just know that what we're going to get up here is going to be bigger than 40, because the 130 is bigger than the 100. So we cross multiply 130 times 40, 5,200. Then we divide by the 100, gives us 52. 130% of 40 is 52. And again, reviewing, we had other forms of those problems that we looked at. We might have had 32 is 40% of what number? Of blank. Again, we start with the 40%, so that's 40 out of 100. This time, though, it's of blank, or read it as out of blank, implies our missing number is on bottom. It's the second number. The 32 is 40%. That implies the 32 goes with the 40. So we still have that relationship there. And this is what I told you I liked about the proportion method is, even though the numbers are in different spots, the missing number's on bottom instead of on top now, the calculation is still the same. We find the two numbers that are diagonal. Well, it's the 100 and the 32. We multiply them to get 3,200. We take the number that's diagonal with our missing number and we divide by that. We divide by the 40. So 3,200 divided by 40 is 80. So 32 is 40% of 80. We had stuff like 14 is blank percent of 40. Well, we had said with the other examples, we always start with a percent. But in this example, there isn't a percent. We still start with it though. Blank percent is just blank out of 100. The difference is now when we fill in the other side, we're going to have both numbers. We're going to have both the proportion and that base amount. 14 is blank percent. Well, that implies that the 14 goes with the percent, or in this case, the missing percent. Of 40, again, if we read that as out of 40, that implies the 40 goes on bottom. So once again, our missing number's in a different spot. It's on top on the left side now instead of on the right side. The calculation, however, is still the same. We find the two numbers that are diagonal with each other. In this case, the 14 and 100. 14 times 100 is 1,400. And then we find the number that's diagonal with our missing number. That's the 40. That's the number we're going to divide by. 35 here. So 35 over 100 is equivalent to 35%. So 14 is 35% of 40. Now, I realize that was a really quick review because there's other types of problems I want to get to more, but I do still want to review that rate method. This is the proportion method. Remember, there was a rate method. And in the rate method, we started by converting the percent to a rate. In other words, that decimal form that we were looking at earlier. So for this problem here, find 35% of 80. 35% as a rate is 0.35. Remember, here we had to use a little bit of that terminology, since what we are given is the base amount. Given the base, and we're asked to find that portion of interest. We're simply going to multiply the base times the rate. Get the portion. So that base of 80 times the rate of 0.35 gives us 28. We get the same number. And again, it's actually probably a little easier of a calculation. If I'm sitting on a job site without paper in front of me, maybe just a calculator on my cell phone or whatever, that's easier to do because I don't have to set up my proportion and figure out which two numbers I multiply and what to divide by. Now, the proportion, as I mentioned last semester, I still feel like that makes fewer mistakes. But when we have this type of problem where we're given the base and we're just trying to find a portion, that rate method is definitely quicker and easier to do. And like I said, you don't have to write it down and figure out how it lines up. You can just punch it into a calculator or your cell phone or whatever and get that result. Like I said, I still think the base is the proportion method is a more reliable method and fewer mistakes. But doing the rate, I understand it on the job site when a lot of those quick calculations, and in most cases, you have the base amount and you're just trying to figure out what that new portion is, it's going to be easier. So knowing when you're able to use that rate method can come in very handy. So on this one, we have a percent of 130%, which is going to give us a rate of 1.3. We're still given the base, which is 40, and we're looking for the portion. So 40 times 1.3 is 52. This type of calculation is actually the main type of calculation that we would be using in construction. And in just a few minutes, we're going to get to examples of why that is so important for us. Here's where that rate method gets sticky, and why I say that the proportion method is better in general if you've got pencil and paper and time to write it out. In this case, I am still given the rate of 40%, the percent of 40%. Turning that into a rate is 0.4. But I'm not given the base here. I am given the portion. I'm asked to find the base. That base amount. So in that case, it is the portion divided by the rate that'll get us to that base amount. So we have 32 as our portion divided by the rate of 0.4 gives us a base of 80. In this last problem, it's a different type of problem still. We're asking to find the percent, or we're going to say find the rate. To do that, we're going to take the portion divided by the base. So here that is going to be the portion of 14 divided by the base of 40. Gives us 0.35 as a rate. Now if we want that as a percent, we have to convert it. Moving the decimal point 2 spots to make it 35%. If you are good with the rate method and you are good at figuring out which form it is. Remembering, when do I multiply by the rate? When do I divide by the rate? When do I divide two numbers to get the rate? It is definitely easier and quicker to use on the job site. Not going to argue with you on that at all. If you're not good at remembering how to do that and you struggle with percents a little bit, this proportion method, just bite the bullet and pull out a piece of paper and write it down, generally produces fewer mistakes. So anyway, I wanted to do that review since it's been quite a while since we did percents before we get into the next step. In this next step, we hit on it briefly last semester, but I want to spend a pretty good amount of time on it today, is percent increases and percent decreases. Percent increase. We are going to start with a beginning amount. And to that, we are going to add an increase. However, the catch is that increase is a portion of that beginning amount. What that means is that this beginning amount is a base. Now we're going to try to find some ending amount, some new amount, or an ending amount. So this ending amount, normally the normal percent problems the examples we looked at here so far, we either were given the base and we asked to find the portion, or we were given the portion and we're asked to find the base. Here we're not. We're given a base and a rate of increase, and what we're asked to find, that ending amount, is actually the base plus the portion. As we saw here, it's the beginning amount plus the increase. In fact, I may have shown it to you a little bit last semester. I use a table much like this to help me working with percent increase and even percent decrease, which we're going to get to in a few moments, to help calculate it out to save on mistakes. And let me show you what I mean. Let's say there is a 7% delivery charge. On supplies. Find the total cost for supplies listed at $1,240. Now, first of all, listed at. When we say listed at or list price, that is that beginning amount, that base amount. List price is the price that's posted on the shelf when you go to buy stuff. So here we have that list price. I just write it as list price. I don't have to write it as beginning amount. I'm going to add that delivery. And that's going to give me the amount paid, or the total cost. So anyway, just like we had mentioned last semester, any percent problems, every item in that problem is going to be described by two different numbers. One of those numbers is going to be a percent. Well, here we have the 7%. That 7% describes the delivery charge. So I'm going to put 7 by the delivery charge on that percent side of my table. But each of these items also has to be described by another number, some sort of an amount, generally a dollar amount. And in this case, we have that dollar amount, $1,240. Now that describes list price. So the other side here is going to be dollars. Now it looks like that is all the information that is given in the problem. But recall, we said this beginning amount is the base amount. That base amount is always 100%. So we know that the percent of the list price is 100%. Once we remember that, once we put that 100% in there for the list price or the base amount, we can now find the percent of the amount paid. Because just like the dollar amounts can be added together, the percents can be added together. 100% for the list price plus 7% for the delivery charge gives us 100 plus 7, or 107% for the total amount paid. On the other side over here, we're looking for that total amount paid. Now, I don't need this middle row, and I'll explain why I don't need it here in a second. When I'm doing these percent problems, I need two items. One item I always need, of course, is the item I'm looking for. I'm looking for the amount paid, so I need the information for the amount paid. The second item I need to solve a percent problem is going to be an item somewhere in the problem where I know both of the numbers. Remember, we said they're always described by two numbers, a percent, and in this case, a dollar amount. So the list price, I know both numbers. I know that it's 100%, and I know it's $1,240. That is what I can use to make my proportion. Now, when we're working with percents, we're used to 100 always being on bottom, always out of 100. It doesn't have to be that. Remember, we saw on Tuesday, we can flip that proportion over, flip both ratios over in the proportion, and we're still going to get the same number. That actually happens here. I could do marker change. There we go. For the list price, do the list price on top, 100 and 1,240 for the top values in each ratio. My bottom values then are going to be the 107 and my missing number. I cross multiply and divide. 107 times 1240. Then divided by the 100 gives us, what did I put it? Did I put that in right? I didn't divide by enough. Okay, so it's 1326.8. So $1,326.80. I missed a zero on my calculation. That's why I'm off by a decimal point there. Well, we can do that. Or if we really want to always have the 100 on bottom, we could say the amount paid is 107 out of 100. And so for the dollar amount, the amount paid is zero, or is the missing number. So that goes with the 107, because that's the amount paid. And the 1240 is for the list price. So that goes with the 100, because they both represent the list price. And you'll notice when we cross multiply, it's still 107 times 1240, just like it was up here. And we're still dividing by 100, just like we did up here. So if you flip those ratios over, as long as you flip both of them over, you're still going to get the same result in that proportion. So let's say Sam purchases supplies listed at $18,210. If 5.5% tax is charged. Find the amount Sam pays. So taxes are pretty much always, I gotta be careful, are usually a percent increase. We start with an amount, sales taxes at least. We start with a base amount, we find that tax and we add it to that base amount. It increases the total cost of the items. Well, here we have that list price, we'll go list price here. We're going to add to it the tax, that's an increase. And we're going to end up getting the amount paid. Let's just put paid down here. Again, each of those items is described by a percent and a dollar amount. Here we have that percent of 5.5% that describes the tax. We have the dollar amount of $18,210. That is the list price. So again, those are the only amounts we get out of the problem, but remember, 100% is always there for us. That is the beginning amount, or the base amount. In this case, that's the list price. And of course, that allows us to calculate the percent for the amount paid. 100% for the list price plus 5.5% for tax means we paid 105.5%. And we're looking here for the dollar amount of what was paid. So again, we need two items. One item has to be the item we're looking for. That's the amount paid here. And then the other item, it has to be an item where we know both numbers. And the only item that we know both numbers for, we know the percent is 100%, and the dollar amount is $18,210. That is for the list price. So those are the two items we're going to use. And again, I'm just going to take them the way they're written. So the list price is 100% and $18,210. The amount paid is 105.5%, or 105.5 if you want to write it that way. Can't mix it though. 105.5. Of course, this is the dollar amount of the amount paid that I'll be looking for. And we cross multiply and divide. So I'm going to put it as 105.5 instead of 105.5. Times 18,210 divided by 100 gives us $19,211 and 55 cents. That's the total amount that would be paid for those supplies. There is, as long as you are able to look at a problem like this and recognize. Oh, somebody have a question? As long as you are able to look at a problem like this and recognize that it is a percent increase and realize you're starting with a base amount that's 100%, and you're adding a percent increase, in this case the 100 or the 5.5%, and realize that you're working with something bigger than 100%, and you can find that that amount I'm working with is 105.5%. We can go back to that rate method and make our life a little bit quicker here. Because 105.5% or 105.5% in the decimal percent is a rate of, if I move that decimal point 2 spots, 1.055. As long as I can recognize that and get to that percent accurately, I can just take my $18,210 and multiply by that final rate of 1.055. It gives me the same $19,211 and 55 cents. Any questions? Now, in business and construction, this happens. And in construction, estimating happens a ton. Let's say you're going to estimate a roof. And you calculate that that roof is going to require 3,200 square feet of shingles. Well, unless it's just a simple ranch style roof, there's going to be waste. Now, first of all, we wouldn't usually write it as 3,200 square feet. We would write it as 32 square. But just for the mathematical side of it here, I'm going to leave it as 3,200 square feet. So if there's valleys and other things, there's a small amount of waste, and even in a simple ranch style, because you have to deal with the cuts at the ends and the ridge and all that. So there's still going to be a small amount of waste, but the more valleys and hips and corners and stuff you have, the more waste there's going to be. So let's say that on our estimate, we want to add 15% for waste. Well, we have our estimated, I shouldn't say cost, estimated area. I'm going to add my waste to that to get my total amount needed. Remember, the estimated area is the full amount. That's 100%. We calculated that as to be the total area of the roof. But to that, we're adding the 15% waste because valleys overlap and corners and hips require cuts. That means the total amount I'm looking for is 100% plus 15% or 115%. So rather than going through and setting up a proportion to do this, as long as I can recognize that a 15% waste factor means I'm finding 150% of my total amount, or 115% of my total amount, I can just take my calculated area here, my 3,200 square feet, and multiply by 115% converted to a rate is 1.15. Oops, get back here. So 3,200 times 1.15, we get 3,680. So when I do my estimate, I'm going to figure materials as 3,680 square feet of roofing material for that roof, of shingles and underlayment and all that good stuff, to make sure I've got enough to cover all the waste and all the cutting. After adding 12% for waste, that figures a shed will cost $36,200. Find the amount added for waste. Well, I just showed you a shortcut for doing these problems. So it's time for me to show you an example where the shortcut might be difficult to use. Adding 12%, of course we know if you add 12% for waste, you've got the 100% full amount plus the 12% for waste. That means you're dealing with 112% of something. And that cost after waste, the $36,200 is after waste has been added to it, because we say after adding for waste. That is the 112%. So if I set up a proportion, the 112% and the $36,200 both represent the amount after waste has been added. The amount, I'm going to just label this here. I'm just going to say after waste. The amount before waste is represented by the 100%. Remember, that's the base amount or the beginning amount, the amount before waste. If we cross multiply and divide here, 100 times 36,200 divided by 112. You get 32,321.43. $32,321.43. Anytime we do a calculation, after any calculation is complete, we should always ask ourselves, does that result answer the question we were asked? First of all, that result, we should know that that represents the dollar amount before waste was added. We are asked to find the amount added for waste. So no, the $32,321.43 is not the amount that answers our question, but it gets us one step closer to that amount. The amount added for waste is just the difference between the initial amount and the amount after waste, or the full amount. So we can subtract 36,000 minus, got to add zeros there for cents, $32,321.43. Is going to give us what here? $3,878.57 is the amount that was added to that for waste. Now you might say, well, why couldn't I just have found 12%? 12% of the 36,200? No, that would not have been the same. That would have been a significantly larger amount, $4,344. Because the 12% comes off of that base amount. That was the amount before waste. So we have to be really careful when dealing with these percent increases. Make sure you understand what it is you're looking at. Let's say Kim calculated materials for a project at $6,500. Kim added $1,300 for waste. What was the percent waste? In other words, what percent did Kim use to calculate the waste? Well, here the 1,300 is the waste. The 6,500 was the cost before waste. I didn't necessarily state it in there, but I'll tell you now, that is the cost before waste. So that percent, we just do the 1,300 over the 6,500 equals our percent over 100, and we can cross multiply and divide. 100 times 1,300 is 130,000. Divided by 6,500 is just 20. That's 20% waste. A little bit more complex problem might be saying, before calculating waste, the estimated cost is $9,000. After adding in an amount for waste, the cost is $10,350. Again, find the percent for waste. Well, the big difference here is up here we were given the amount for the waste. Here we're given the prices before and after. To find the amount for waste, you have to subtract. 10,350 minus 9,000 is $1,350. That's the amount for waste, the dollar amount. Now we can use that to find the percent waste. How much out of 100 is that 1,350 out of 9,000? And we'll cross multiply and divide. 100 times 1,350 divided by 9,000 gives us 15. That's 15 out of 100, or 15% waste. Oh, we have percent increase problems. We can also have percent decrease problems. Most suppliers will give you some sort of a contractor discount or a business discount. They call it a trade discount is the general term for it. So Stacy receives a 12% trade discount. How much does Stacy pay for supplies listed at $4,500? So again, we have a list price. But this time we're not adding a tax or a delivery charge or a waste factor. We are subtracting a discount. To get the amount paid. And again, we'll go back like we did for the first couple of examples of percent increase. Each item is described by a number and by a dollar amount. We have the 12%, that's the percent of the discount. The $4,500, that is the dollar amount of the list price. And of course, 100% is always there. The list price is always 100%. So we are able to find the percent to describe the amount paid. We just have to be careful. It's not 100 plus 12%. It's 100% minus 12% because the discount is subtracted. So 100 minus 12 is 88% is the amount paid. And of course, that dollar amount is what we're looking for. Once again, we need two items to describe to make our proportion. One of those items is the item that is the amount we're looking for. In this case, that's the dollar amount paid. And of course, we have the 88% that describes that. And the other item is the item that we have both numbers to describe it. We have 100% for the list price and $4,500. So the list price is 100% and $4,500. The amount paid is 88%, and that's our missing price. So we're going to cross multiply and divide here. 88 times 4,500 divided by 100 gives us 3,960. So Stacy would only pay $3,960 for those supplies that are listed at $4,500. along with the quiz that I'll post on Blackbird for you, there's going to be a packet. The packet, I'm going to have you do pages 107 through 122. Now, in those pages, now most of that is reading. But within those pages, there are gray boxes. And in those gray boxes, there are problems for you to work on. So throughout those pages of that packet, work on the problems in the gray boxes. So we have about 17 minutes left. I cut you guys a little short. Sorry about that. You guys can have that time to get started on your homework. I'll be on the